So we have been using the first derivative test to find relative extrema. Today we're finding relative extrema for functions that are not continuous, such as this rational function. We know the first step is to find critical points, where we take our derivative, we set it equal to 0, and solve to get our critical points. We also know critical points are where f prime doesn't exist. So for example, if we look at f of x here, we see that this function is undefined when x equals 3. In fact, we know specifically when x equals 3, we have a vertical asymptote here. So 3 would be a critical point because that's where this function is not defined, and if it's not defined, then we know f prime doesn't exist. So I want to do this second problem together, this number 2. So we are instructed to find all local extrema for this function. And for this function, we can see that it's undefined when x equals -3. We know we have a vertical asymptote here, not a hole. Recall, we only have a hole if we are able to divide out. If this was x plus 3 on the top, x plus 3 on the bottom, then it would be a hole, but in this case, it's a vertical asymptote. Okay, so let's find our other critical points. So to find f prime, we have to do low d high minus high derivative of low all over low, low. And we're taking our derivative and setting it equal to 0. Well, this looks like it's going to be a lot of work, but let's see what happens. When I have a fraction equal to 0, I could put 0 over 1, and I can cross multiply. So I do not have to worry about this denominator. I have this whole numerator equal to 0. So let's rewrite this. Put my 5 in front. X plus 3 cubed minus, here I have 5x times this whole thing, so that's 15x, x plus 3 squared, and this all equals 0. Well, instead of multiplying this all out, let's look. Can I factor this? I should always see if I can factor, because if I factor, sometimes then I can simplify and make my life easier. So anytime we go to factor, we should always look for a GCF. And I can see if in both of these terms, I can factor out 5. But also notice I have an x plus 3, here it's cubed, and here I have x plus 3 squared. So in both of these, I have at least an x plus 3 squared. And so what's left over? In this term, I took out the 5, I took out 2 of these, so I'm left with one of them, minus, here I took out 5, so I'm left with 3x, and I took this whole thing out, so this is it. I just made this a lot easier. And anytime I have a product, something times something equals 0, by the 0 rule, I can just tee this off. And so here I have 5x plus 3 squared equals 0. And in here I have x minus 3x, so that's negative 2x plus 3 equals 0. When I solve this, I can divide out my 5. I have x plus 3 twice equals 0, so therefore x just equals negative 3. And here I could subtract 3, divide by 2, so x equals 3/2. So I found 2 critical points, but notice one of our critical points happens to also be where our function is undefined, and therefore I know I could place it on here, but even though I place this on the number line, we already know what's happening here. Could I have any relative extrema here? No, because we already said we know what's happening here. We have a vertical asymptote. You can check it anyway, but it's not even necessary to check because we know there's a vertical asymptote here. We still need it on this number line because this is where we divide. We cut it off. So I know when I'm checking to see if this is a local extrema, I need to check a point in here and a point after. So I need a number to check greater than, than -3, but less than 3/2. So we can test 0, and 3/2 is 1.5, so we can check 2. And so now, remember this is f prime, down here is f. We're plugging 0 into the derivative. When I plug 0 into the derivative, so we can plug it back into here, let's see what kind of number we get. Down here, I know I end up with a positive number, right? If I plug in 0 here, I get 3 cubed squared. Regardless, this will be a positive number. So what do I get in my numerator? Here I have 0 plus 3, so this is 3 cubed, 27 times 5. So 27 times 5, we get 135. And then we can plug in 0 here. Oh, but look, once I plug in 0 here, this all goes to 0, so I know I have 135 over a positive number, so this is positive. Therefore, my function is increasing before 3/2. And then let's plug in 2. Well, again, if I plug in 2 here, I know my denominator is positive, so I'm not worried about this. Let's plug in on top. So if I plug in 2 here, I get 2 plus 3 is 5 cubed is 125 times 5. And so just in case, you can always just do a sidebar. Right, if you have no calculator, 5 times 5, 25, 10, 12, 5 times 5 and 1 is 6. We get 625 minus, now we plug in 2 here. So in here we have 10 times, if I plug in 2 here, 2 plus 3 is 5, 5 squared is 25, 25 times 3. And so this number, 10 times 75, is certainly bigger than 625. Right, 10 times 75, we know is bigger than 625. It's certainly bigger than here, so this was to be negative. And so my function's going down. So I can see that we have, if it's positive to negative, right, we're going up and coming down. We have a local max at x equals 3/2. So again, when you're doing these, just make note, what would make this function undefined? Either way, you're going to find the derivative set equal to 0, but notice here, all real numbers are included. Anything squared will never give me a -1. Over here, notice your function is only defined where x is greater or equal to -6. But again, find your critical points, set them equal to 0, and follow the same process.